Alright, this is HRW96P019. We've got a 16 Newton horizontal force F pushes a block weighing 4 newtons against the vertical wall. The coefficient of static friction between the wall and the block is 0.67, and the coefficient of kinetic friction is 0.47. Assume that the block is not moving initially. Okay, so let's draw a free body diagram to get us started. Let's see. Here's my block. Now it says it weighs a certain amount. That means they're not giving you the mass. They're just giving you how much it weighs. So that's the force of gravity pre-made for us. Weighs 4 newtons. That's for me. You're going to have a different number. It also says it pushes force of 16 against the wall. So I've got a force going into the wall. 16 newtons. And the wall's going to push back. Normal force. Okay, and then finally there's some friction. So the friction is always opposite the motion of the block. It's not moving initially, but if it were to move, it would fall. So friction must be the opposite of that. Friction. Okay, so this is our free body diagram. I'm going to write a little bit more information up here so I can then pull this into full screen. Mu s equals 0.67, mu k equals 0.47. Alright, let's go wide full screen. Boom. Okie dokie. Well, let's do Newton's second law in the x and the y direction. So F net in the x direction equals mass times acceleration in the x direction. So in the x direction, I've got 16 to the right, so I got 16, minus the normal force to the left. I got mass and acceleration. Well, this should not accelerate in the x direction because if it did, it'd be moving either into the wall or it would kind of like float away from the wall. And that just doesn't make any sense. So that really should be 0, which means 16 minus the normal force equals 0. So the normal force is 16. 16 newtons. Okie dokie. Well, that's good. So now I can go and find the frictional force. So first thing we got to see is, well, does the block move? That's the first question it asks. If the coefficient of if the friction, the maximum static friction, is bigger than the weight of that's pulling it down, then acceleration will be 0. Nothing's going to move. So let's look at that. F net in the y direction, okay, is going to be mass times acceleration. So we've got friction force up minus 4 newtons down. Well, friction force is mu times the normal force. So the maximum static friction, max, is mu s times n, which in this case is 0.67 times 16 newtons. Okay, put that in a calculator, and I get 10.72 newtons. Okay, that is way more than the weight of the block. So I'm not even going to reach my maximum. Basically, the static friction is going to be exactly enough to keep my block from falling. It could go up to 10.72, so 4 is well within the limits. That means the acceleration must be 0. So this block is not going to move. It is staying there. Which, will the block move? No. Okay, so now it says, in unit vector notation, what is the force exerted on the block by the wall? Okay, let's go back to that free body diagram. Oops, that's the wrong way. That's the last problem. Here we go. Okay, so the wall, what the wall is doing, let's see. Let's use this tool. I never get to use this tool. Here we go. The wall is doing this force, and it's also creating the friction force. I mean, where does the friction come from? It comes from the wall. So those are the two things being done by the wall. So in the I direction, that's the X stuff, we said this was 16. Remember we found that out from the other page. Okay. Okay, we said this was 16. It's to the left, so it'll actually be negative 16. That's why this is negative 16 newtons in the I direction, the x direction. And then the friction is 4, and it's up, so in the y direction that would be positive 4. So that is why we have negative 16I plus 4J for our answer of the univector notation, the force created by the wall. And that's it. That's the end of that problem.